Hey guys, this is Coach Lowe, and let's talk a little bit about linear measure. This is Chapter 1, Section 2. So make sure you have your Chromebooks out and your notebook and you're ready to go. So you can either do this on your Chromebook totally in a notebook, or you can write in a composition notebook, take pictures, and upload it to your notebook. But you need to have documentation for taking these notes. All right, so let's talk about linear measure. Well, we've already talked a little bit about lines, and we know that lines don't really have a stopping point. They just keep going on and on forever. Even though we put arrowheads on the end, they just continue on. So let's look at a line segment. A line segment is different in that it has a starting and a stopping point. No arrowheads on the end. So it has a unique length, starting and stopping point. So it's different than a line because it can be measured. So we can bust out with the ruler and we can measure the length of this line segment. It has a starting and a stopping point. We've already talked about that. So that helps us determine what the length is. Otherwise, if there were arrowheads on the end, we couldn't find the length unless we were finding it between 2 points that were on the line. All right, so definition of betweenness. Point B, I'm going to try to keep it out of the middle here. Point B is between points A and C if and only if two things have to happen. So if and only if means we can go either direction with the definition. So let me go ahead and write this. Point B is between points A and C. All right, so if and only if, 3 words, if and, oh, that's 4 words, right? If and only if. You can write those out, or you can just put this, IFF. So don't think that I've misspelled something. I will do that from time to time, but this means if and only if. That means the definition is true reading it. Point B is between points A and C if the next part, and then the next part if point B is between points A and C. So you'll see what I'm talking about in just a second. If A, B, and C are collinear, so remember what collinear means, they're on the same line, and AB, segment AB, so this length right here, plus the length of BC, so this length right here, is equal to the length of AC. So when we're talking about length, we don't put the little segment line above the letters. So let's go back to the if and only if. That means I can read it this way. Point AB is between points A and C if this is true. So if they all lie on the same line and the small sections add together to be the large section. Now let's go the other way. A, B, and C are collinear and AB plus BC is equal to AC if B is between those 2 points. So that's what that means by if and only if. So the hypothesis and the conclusion, you can switch places with those. All right, so let's draw an example of 3 points. So we have an example where we have 3 points and B is between A and C. So now I want you to pause the video and I want you to draw an example of 3 points where B is not between A and C. And I want you to tell me which part of this does it fail. So which part of this is not true on that. So you go ahead and draw your example. You can take a picture of it and put it in your notebook. Be ready to explain that when you come back to class. So pause the video and do that. All right, now that you're back, let's talk about my first example, and I want you to draw a line segment, and we're going to label this line segment RST, and we'll put R here and S about here, and then we'll make T the end point. And the distance from R to S is 2.5. And the distance from S to T, sorry, from R to T is 6. All right, and let's go ahead and we'll make this meters. Let's go ahead and do that. All right, so my question to you is find the length of ST. So we can see that we have betweenness here. S is between R and T. We see that those 3 points are collinear, And now we know, since it's between, we know that RS plus ST has to equal RT. So these two small pieces, RS and ST, added together has to make the long one. All right, well, if that's true, then can you think about how to find this section right here? Go ahead and pause the video and figure that out. All right, so now that you're back, we can take this long length, this whole thing, so we know the whole measure, and we can take this little section right here out, and that will give us the length of ST. So taking something away or taking something out means we need to subtract. So 6 minus 2.5. Oh, awesome. We get to work with some fractions, don't we? So breaking this up, you can either change this to a decimal, or you can do 6 minus 2, which is 4, and then take away like $4 minus 50 cents. Everybody could do that, right? We can work with money. So 3.5 meters would be this piece here that's not labeled. All right, so let's do a quick check. 3 plus 2 is 5, and then 2 halves make 1 whole, so 5 and 1 is 6. All right, so we'll throw back number sense there, right? Yay! All right, second example. Let's draw another line segment. And we're going to label this one PQR. All right, and here is your info for this one. Find the value of X if, oh, and QR, sorry, you have to find two things, and the length of QR if PR is 42 and PQ is 2x minus 3 and QR is 3x. There goes that blue again. All right, so I like to label the figures. I like to draw pictures when I'm given a problem. So if they hadn't given me, if they'd just given me this information with no picture, I would draw the line segment and go ahead and put those pieces on the picture. They gave me a picture because they would have to tell me which one's between in this case, or I wouldn't know. But they gave me a picture on this one, so I drew that for you. Now I usually label everything, so I would come over here and put 42 for this whole length, and then PQ, so this distance right here is 2x minus 3, and then I would go ahead and put QR on there as well. So QR is 3x. All right, so now the goal is find the value of x, and then we'll find the value for QR. So if you want to pause the video and try that, that would be great. All right, now that you're back, let's see what your work looks like. So from our betweenness statement, and these points are collinear, they're all on the same line, and Q is between P and R. So what do we need to do to be able to find the value of X? All right, well, if those things are true, then now I know that PQ plus QR equals PR. In other words, the distance from the distance of this little segment plus the distance of this little segment equals the entire segment. All right, so let's plug in what we know. Well, we know PQ is 2x minus 3, and we know that QR is 3x, and that's equal to this entire length right here, which is 42. All right, now we get to solve this equation, right? So this is a little bit of review of our review. All right, so 3x, combining like terms, 3x and 2x is 5x minus 3 equals 42. Hopefully this is fixed soon. Equals 42. And then two steps to solve, we're going to add 3 and then divide by 5. So adding 3 to both sides of this equation gives me 45 on the right side. So 5x, love it, 5x equals 45, and then dividing both sides by 5, we see that x is 9. All right, so we found the value for x. That was part 1. Part 2 is we have to find the length of QR. Well, the length of QR is 3 times x, so 3 times 9, because that's what we said x was, and 3 times 9 is 27. So QR is 27, and they didn't ask you this, but what if we were supposed to find PQ? What would be some ways that you could find it? Sure, you can subtract 27 from 42. We can definitely do that. So 42 minus 27 is 15. I can also plug 9 in here and do 2 times 9, which is 18 minus 3 is 15. So either one of those would work. And then our quick check is 15 plus 27, 42. Does that add to be 42? And the answer is yes, so we know we got that problem right. Whoop, whoop. All right, last thing. This one is quick, so hang with me for a second. Let's talk about congruent segments. So you know hopefully what congruent means, or maybe you don't. So congruent means equal in measure. So if I ask you to draw 2 congruent segments, you should draw 2 segments that are the same length. They don't have to be going the same direction, but we just want 2 segments that are the same length. Now I wouldn't ask you to draw 2 congruent lines. Why? Yeah, because lines can't be measured, right? They just keep going. But congruent segments, I can ask you to do that. So when we mark congruent figures, we mark them with slashes, and they're usually red in your book. I don't really care what you mark them with in your notes. It doesn't matter to me. You can mark with any color. But when I see that slash, and it's usually red, so if you want to continue that theme, that means that these segments are congruent. So let me go ahead and label these. This is segment AB. Excuse me, and this is segment CD, and this is the symbol that we use. AB is congruent to CD. So segment AB is congruent to segment CD. So if you want to write down next to that is congruent to, that's what that equal sign with the little whoopee on the top of it. So, and we're not talking about measuring those. We're talking about the length. We are talking about the measure as well, but we are saying segment, not the measure of the segment. So segment AB is congruent to segment CD. All right, so equal sign with a little squiggly on the top means is congruent to, or is equal in measure. All right, so you should be able to answer some questions when you come back to class after watching this video and taking notes. If you need to review it, please do so. Remember to use those bubbles wherever you decide to place them, or if you're going to use a text box, whatever you decide to do. If you have any questions, go ahead and jot those down so that you can ask me when you come back to class. All right, guys, I'm finished. This is Coach Lowe, and I'm out.